Hello everyone, my name is Mahesh Kumar from DD College Dehradun. Today I'll going to explain you about a very interesting topic which is IP addressing. So let's get started. IP addresses. You must have heard about this term. But what does it mean? The simplest definition of an IP address is like this. An IP address is a numerical label which identifies and locates a device on the internet. Now let's understand this definition. As you all know, internet is a very large network. There are billions of devices on it. So, how those devices are identified? This is what IP addresses are doing. Every device on the internet have an IP address, also called an IP. These IPs are just numbers, which is unique for every device on the internet. These IP addresses are what is used to identify those devices and also to find the location of them so that the data can reach its destination properly. These are some examples of IP addresses. As you can see, they are made up of 4 decimal numbers, separated with dots. There is another kind of IP address which looks like this. Here it is made up of 8 hexadecimal numbers, separated by colons. So, what are these IPs representing? Actually, these are 2 different versions of IP addresses. The first one with dot separator is IPv4 and the second one with colon separator is IPv6. Now let's see the difference between them. IPv4 is the original version of IP address that is used for internet. It is a 32-bit address. That means it takes 32 zeros and ones to represent this address in binary form. So the total number of addresses are 2 raised to the power 32, which is approximately 4.2 billion. It looks a big number, but it is not enough. That's why IPv6 is developed. IPv4 addresses are represented by 4 decimal numbers, which are separated by dots, where each number takes 8 bits. So the total length of the address comes to 32 bits. The whole address is separated into 2 parts. The first one is network ID, which identifies the network, and the second one is host ID, which identifies the host in that specific network. The length of the network ID and host ID depends on the class of IP address. In IPv4, there are 5 classes A, B, C, D and E, which are shown in the table. As you can see, each class have a specific range of IPs and a subnet mask. This system of classful addressing is replaced by classless addressing because it doesn't provide so much flexibility, and because of it, IPv4 addresses are exhausting very quickly. But still, it is not enough to stop the exhaustions. So, IPv6 is developed. IPv6 addresses are 4 times more lengthy than IPv4. That means their total length is 128 bit. So the total number of IPv6 addresses are 2 raised to the power 128, which will be enough for very long time. They are represented by 8 segments which are separated by colons, and each segment contains 4 hexadecimal number. So length of each segment is 16 bit and the total length of address come to 128 bit. The length of network ID and host ID in IPv6 is always same. First 64 bit represent network ID and remaining 64 bit represent host ID. So we talked about basics of IP addresses and their versions, which is IPv4 and IPv6. Now let's see another interesting topic, which is private IPs. So what are private IPs? There are some reserved range of IP addresses, which you can see here. Any address in this range considered an private IP. And private IPs are not have to be unique. More than one device on the internet can have same private IP address. This is because private IPs aren't represented on internet directly. Device which have a private IP is a part of private network, and the entire private network is represented by a single public IP given to a router, and that router connects the private network to the internet. There are many private networks on the internet, each with unique public IP, but there are devices on different private networks with same private IP. So now we reach at the end of the video. Hopefully this is knowledgeable for you. Now you know what are IP addresses and why they are important for the internet. So thank you for watching.